So far, the demonstrations have pretty much ignored the save functionality. Why? Because there's all sorts of fiddliness involved when we have to actually save data. Is it a new item? Then there may be specialized operations to perform. To track if the item is new, each entity class needs an isNew property. Is the data actually changed? If we display data to a user, they may look at it and not actually change anything, so we don't need to save it. To track whether the user has made changes, each entity class needs a hasChanges property. Is the data valid? To track that, each entity class needs an isValid property that calls its validate method to determine if the data is valid. What if the user deleted the item? It is normally good practice not to actually delete any data, especially if that data is related to other data in the application. For example, an order is associated with a customer. If the customer is deleted, the order can't be displayed. Instead, add an entity state property to track whether an item is active or deleted. So every entity needs another property, entity state. Do we want to add each of these properties to every entity class? I don't think so. Let's instead define a base class that has these properties. Every entity class can then inherit from this base class to access all these new properties. When building a base class, we have two choices. We can build an abstract class or a concrete class. An abstract class is an incomplete class with at least one property or method that has not been implemented. Because an abstract class is incomplete, it can't be instantiated. That means we can't use the new keyword to create one. An abstract class is intended for use as a base class and not used on its own. Define an abstract class using the abstract keyword. A concrete class is a normal class like we've been creating so far in this course. A concrete class can be instantiated. That means we can use the new keyword to create one. A concrete class can be used as a base class or on its own. When creating a concrete class is created by default. No additional keyword is required. Our new entity-based class is only meant to be used as a base class, so we'll build it as an abstract class. There is one more concept to cover before we dive into building our base class, and that is a sealed class. A sealed class is a class that cannot be extended through inheritance. Sealing a class prevents extension and customization. If you build a class and want to ensure that no other classes extend or override its functionality, consider marking it as sealed. Seal a class using the sealed keyword. Since we are building a base class, we want it to be extended and not sealed. But if we don't want any other code to extend our entity classes, such as our customer or product classes, we could seal them. Now let's build our base class.